Greetings! In this interactive demo, you'll see how Clockwork's software-driven fabric makes AI workloads resilient to failures like link flaps or network problems, and speeds up performance when there's network contention. This is a 4-node GPU cluster. Each node has 16 100 gigabit NICs. eCMP 4 and 5 are in one rack, and 6 and 7 are in a second rack. The cluster is currently idle, so I'm going to go ahead and kick off some workloads. I'll start 2 all-reduced jobs. For the first, I'll use the standard nickel driver. And for the second job, I'll use the Clockwork nickel plugin, which will make the job resilient to failures. After a few seconds, you can see the 2 jobs start running. Remember, eCMP 4 and 5 are in one rack and 6 and 7 in another. Since Job 1 operates across eCMP 4 and 6, and Job 2 across 5 and 7, both cross the network spine and both contend for bandwidth. That's why many of the ports are red to indicate high latency. The aggregate throughput is only 1 terabit per second out of a theoretical max of 1.6. Similarly, each 100 gigabit NIC is only getting around 62 gigabits per second. Now I'm going to turn on dynamic traffic control to eliminate the contention. I'll click the on button here. And look at that! We immediately see a nearly 50% performance improvement. This is because Clockwork Dynamic Traffic Control has paced and routed the traffic across the most optimal paths. In aggregate, we're getting 1.45 terabits a second, which is pretty close to the theoretical max, and each NIC is getting about 90 gigabits per second. Now, I'm going to introduce some link flaps to see how they affect the 2 all-reduced jobs. First, I'll pull a cable from a NIC used by Job 1, and I'll also pull a cable from a NIC used by Job 2. NIC 1 in nodes eCMP 4 and 5 turn gray, indicating they have failed. And the first all-reduced job completely stops. This is the one using the standard nickel driver. But the second, the one with the Clockwork nickel plugin, just keeps running. The performance drop is because the traffic from the failed port is being rerouted across the other ports. Now I'm going to plug the cables back in, first for Job 1 and then for Job 2. NIC 1 in nodes eCMP 4 and 5 now turn green again to indicate they are working. But Job 1 never recovers, so work is lost and you would have to restart it manually from the most recent checkpoint. But Job 2, the one using the Clockwork nickel plugin, returns to full performance. What you just saw was how Clockwork first eliminated the network contention at the spine through dynamic traffic control and then made the AI workload resilient to a NIC failure. All this was done using only software, and it works on rocky InfiniBand and Ethernet networks. Please contact us today to organize a trial. Thanks for watching the demo.